Okay, so let's start. Am I audible to you all?
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. So in the previous class, I have taught you materials requirement planning, and and I think that you have learned how to solve the material requirement planning problems, and so you can work out, isn't it? For any product, you should practice. Okay, you practice more and more examples, so it will be very much clear to you. Okay, so today I'll start your routing. Okay, routing. I think from the name itself, it is very clear. Routing means in routing means. Can anybody tell what do you mean by route? Routing means path, isn't it? Okay, so
Yes, ma'am.
routing means path means. So by this routing in production planning means that we have to determine the most advantageous path that should be followed from department to department and from machine to machine unless and until the raw materials are converted into final product. You know that when you walk from your home to your college, there are more than two or three ways, isn't it? So what you used to do, you used to find the shortest way that will reach you in right time and quickly. So the same thing is followed in plant also. Routing means to produce a product there may be three or four routes or more than that. So you know that, but you have to determine which route will lead you the product at shortest time and least material cost so that you can save the money. Okay, so that is routing. So routing is defined as the selection of proper path which each part of the product will follow while being transferred from raw materials to the finished product. This is your routing. So I will tell you about the routing steps. Okay, routing, routing. So different steps. Number one, first point is analysis analysis of the product. Analysis of the product. All of you please note down analysis of the product. Then make and buy decision. I'll explain each and every point. Make and buy decision. And third one is raw materials requirement. Raw materials requirement. Fourth is sequence of operations. Sequence of operations. Fifth is machines to be used. Machines to be used. Sixth is time required. Time required for each operation. For each operation. Okay, so these are the steps in routing. So routing is the, in short I'm writing it, routing is the determination of most advantageous path. Determination of determination of most advantageous path. Most advantageous path to convert raw materials into finished product. Raw materials into finished products. Okay, you can write definitions from your books for your understanding only. I've told you in short that is the meaning of your routing. Okay, routing procedure involves analysis of the product. As you have seen in the previous case that for fire extinguisher it is composed of three subparts. Similarly, all the products are mostly made up of many subparts. So first what you have to do, you have to analyze the product. Analysis in the sense means that you have to you have to divide the product into so many subparts. You should know which that means it is consist of how many components. Okay, so that is the analysis of the product. Then second one is make and buy decision. In the first case, you have already identified how many subparts are there for the final product. Then you will decide whether all these subparts are available within the firm or not. If not available, which out of these subparts, which parts they can manufacture and which part they can able to buy from the nearby sellers. So that thing has to be also noted down and that has to be finalized. So second step is also clear, make and buy decision. So before going for the production process, all these exercises used to be done. Then raw materials requirement. Now we have identified which are the subparts that we need to manufacture it. So what are the raw materials that are required for its manufacture? And from whom we can purchase, nearest supplier, nearest buyer. If the suppliers are far away from us, it will increase the cost of materials. And of course, quality also matters. Good quality thing at the nearest supplier. Okay, then is the sequence of operation. That is also very important thing. You have got the material, then these materials have to be processed from your raw material to the finished one. It involves a sequence of operations, and this these sequence of operations has to be enlisted. In the sense, the first step what it will be done, second step what it will be done. Accordingly, all the machines should be kept very close to each other, so there is not any wastage of time. If after one operation the immediately that part will be going to the next machine for second operation, and this sequence will be following, so that there is no wastage of time. And time is also very precious, and if more time you are taking means the cost of the product will increase. Okay, so then after that you will find out the sequence of operations. Next, which machines will be used for working, suppose for turning, milling, grinding. So what kind of machines you will be using it. So these machines has to be listed. These machines required, whether these are available in our plant or not, whether it is functioning properly or not, if it requires any overhauling or not. All these things have to be analyzed so that there is no wastage of time when the actual process used to start. Then, what is the time required for each operation? We have already in the fourth step, we have determined that these are the sequence of operations. Now we have to calculate what tentative time will each operation will take to take from start and finish of the job. So accordingly, we can compute the total time of operation by which the product will be produced. Okay, so these are the steps of your routing. Have you followed this routing?
Yes, sir.
Okay, so now for routing again we use route sheets. Okay, route sheets, route sheets. Because whatever we have discussed, okay, whatever we have discussed, I make you understood. But officially the plant people use route sheet. So what are these route sheets? Route sheets, that means it's a document. It's a document which lists the exact sequence of operation, exact sequence of operations needed to complete the job. That is your needed to complete the job. Okay. So another term is the root sheet, and another term that is used with all these sheets is your operation sheet. Operation operation sheets. Operation sheets is also the sequence of, it is the sequence of, we cannot say the exact, you can see here the word exact I have used in the root sheet. In operation sheet it is the sequence of operations. It is the sequence of operations needed to complete the job. Needed to complete the job. I will tell you the difference. Complete the job. See, usually root sheet and operation sheets are the same one with very little difference. Sometimes it differences arises. See, root operation sheets means it is the sequence of operation that are needed to perform the job. We will enlist that these are the sequence of operations. These are the type of machines that will be using. These are the tools. These are the jigs and fixtures we will be using. These are the setup and operation time we will be using. This is a standardized operation sheet is a standardized one. But root sheet, what happens when we actually go for the manufacture? Sometimes happens that after the work has been finished by machine one, it has to then again it has to go to machine 2, but in machine 2 some already job is being done, so it has to wait. So if it has to wait means you have to again a little bit revise your plan. So it may not happen if you have done everything in a proper plan. So it may not happen. In that case, your root sheet and operation sheet will be same. If there is any waiting time, some sort of disorder occurs, suppose machine breakdown sometimes occurs, you have to revise your plan. That case, you are using the root sheet. That is the exact sequence of operation that is needed to complete the job. Okay, that is your root sheet and operation sheet. And again, routing depends upon your layout. Now the question comes, what is layout? Layout means it is, you know that for manufacture of any item or any product you need machines, no doubt. Raw material, you need materials, and besides materials you need facilities, or machines and services, that means the operators who will be operating the machines. So all these machines used to be arranged in a proper sequence. I've told you in the previous step that all the machines, that the sequence of operations, as per the sequence of operations machines are arranged, so that there is no or little wastage of time while going from one machine to another. That is known as your layout. Layout means layout layout means systematic systematic organization systematic organization and grouping of facilities, and grouping of facilities and services that will be used. Okay, that will be used to manufacture the goods or the product. That is your layout. Again, layout is of different types. I think you might have heard about the product layout. So again, I have told you that layout means grouping of machines and services. So product layout, then process layout, then fixed position, fixed position layout. Okay. Layout is very clear. It is a systematic organization or grouping of machines, workers, services, everything else. So in case of product layout means, I think from the name itself it is very clear that product means that the machines are grouped as per the product. So that means it is used for the mass production, like all the machines that will be used by for used to manufacture a product will be grouped together, like the product will be going from machine 1 to machine 2, then machine 3, machine 4, and all machines will be in a line. That's why the product layout is also known as line layout, that all the different machines are interconnected in a line, so that there is no wastage of time. So different so the part goes from one machine to another, and it produces the final product within a shortest time. So it is known as product layout. So it produces a standardized product. So product layout produces standardized product. Standardized product means you know that it's a mass production standardized product, like in case of your automobiles. Okay, all these are all or all the part that need to be manufactured, all the machines are connected, so the part goes from one machine to another, so it is used for the mass production. That's why in mass production cost of your product is less, because there is no wastage of time. Plenty of parts are produced, or identical parts are produced daily. But in case of your process layout, it is also known as job shop layout. That means it is different for an individual product. So it is based on the process. It is based on the process, means where identical processes are categorized together. That means material is supplied to a machine. It is loaded anywhere in the factory that contribute that means conduct the first operation. So there is no necessity that if the second machine will be very nearer to the first machine. It may be that means that for the next operation, half processed goods are taken to some other machine, which may be located in some other part of the factory, maybe far away. Like in case of your furnitures, I'm giving you one example. Mass production, your automobiles, so and mostly then your aircraft industry, then your oil refinery. So these are for the mass production. Okay, and this is the process layout based on an individual product as demanded by the customer. So it is a process layout is a customized layout. Okay, and fixed position, I think from the name itself very clear. Fixed position layout means that the product will not move. Okay, product will not move. um, that means the machines and the workers will come to manufacture the product, like in case of your maybe ships. So because it's such a big product that we cannot move the product, so machines, we have to bring the machines, and that's why it is a fixed position layout. Product is fixed, and so men and machine will be coming together and they will be producing the product. So your routing depends upon type of layout, whether it is product layout, whether it is process layout, or it is your fixed position layout. Okay, then we will go to the one example of route sheet. I was telling you about the route sheets. Suppose let's say one example. Suppose one material is given to you, that is your mild steel. Material, mild steel. Okay. And suppose quantity maybe 50 you have to produce. Quantity 50. Okay. Then, and this is a figure, you have to cut one slot. This is one example I am telling you so that you can know what is route sheet. Suppose its length is 300 mm and its height is 50 mm, and the slot that you need to cut is 40 mm deep. Okay, so we will prepare a route sheet. First, suppose let's say department. First column is department. Then is machine. Then operation. Then description. What sort of job we will be doing? Description. Then tool. Jigs and fixtures. I think jigs and fixtures you might have read in MST too, isn't it? Jigs and
Yes, ma'am.
jigs and fixture. Then time. Setup. Setup. Then is your operation time. Let's say in minutes. Okay, this is the root sheet. Oh, sorry. Okay, so you have to cut the slot. Okay, first of all, to increase the mechanical properties, we are first what we are doing, we are forging it. So first it will be going to Smithy department. Okay, Smithy department, they will be using power hammer. Which machine they will be using? Power hammer. Okay, what is the operation? It is operation number one. First operation. Description, what they will be doing? They will be doing forging. What tool they will be using? No tool. Is jigs and fixture required? No. Sorry, I have written here, na? Okay, let me do one straight line. Could you get it? Could you see it? Little bit lines are not clear, but I think you could get it now.
Yes, ma'am. Yes, ma'am. Okay.
Okay, okay, okay,
Yes, ma'am.
okay, okay. Then tool, then jigs and fixture. You don't need any jigs and fixture. Okay, what is the setup time? Suppose let's say it is 3 hours. 3 hours. So let's say let me just convert this in. Okay, I'm not keeping anything. I'm not writing unit of this time. Some here it is taking 3 hours. In some operation, it may take time in minutes. So let it be. Let me write in hours here only. Suppose let's say setup time is your 3 hours. Okay. And what is the operation time? Setup time is different. Operation time is different. Suppose operation time is suppose 20 minutes. Okay. So first job done, Smithy. Then suppose let's say to further enhance the properties, we are going for heat treatment. I think you might have heard what is heat treatment in your material
Yes,
science.
ma'am.
Okay. Heat treatment, what happens in heat treatment, your mechanical properties used to be improved. How? Because it increases your grain size, that microstructure. And especially in heat treatment, what happens? We used to melt any material below its melting temperature, and what we do, we used to cool it slowly in the atmospheric air, or by sometimes quenching also we used to do it. So, but usually we do like that, so that metal is heated below the melting point and it is allowed to cool in air, so that its mechanical properties in terms of ductility increases. So that's why we are doing the heat treatment. How heat treatment is done? It is done by means of a furnace. So what machine we will be using? We are using furnace. What is the sequence of operation? It is the second operation. Okay. What we are doing? What kind of heat treatment we are doing? It is normalizing. 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 What tool we are using it? No tool. Do we require any jigs and fixture? No, we don't require it. What is the time? What is the setup time? Suppose let's say to set up the oven we are using 4 hour. And what is the heat treatment time? Let's say it is 3 hour. Okay. Now, now we have to go to the now we will go. We want to cut the slot, so we will go to the machine shop. Okay. Now we will go to the machine shop. Machine shop. We want to cut one slot, so we'll go to the slaughter machine. What is the sequence of operation? It is a third operation. What you want to do? You want to make a keyway. Okay. What tool you will be using? You will be using a slotting tool. Do you require any jigs or fixture? No. What is the setup time? Suppose let's say 10 minutes. And what is the operation time? Let's say it is 30 minutes, whatever. So this is a route sheet. In this way, you can calculate what is the time, total time you will be taking, and what are the sequence of operations that you will be done. I think route sheet is now clear why routing is essential, isn't it? Routing is very much essential.
Yes, ma'am.
Okay. Now, what are the advantages of routing you will do? Advantages, advantages of routing. It is highly essential. Okay. First one is efficient utilization of resources. Okay, that is the most important thing. Efficient utilization of resources. Okay. Number two, reduction in manufacturing cost. Reduction in reduction in manufacturing cost. Okay. And third one is improvement in quality, improvement improvement in quality and quantity of the products. Okay, so these are the advantages of the products. So this was all about your routing, what path should be followed. So if we summarize that routing is a process by which you can know what path the product will be passing through, what kind of machines it will be using, what kind of operations it will be using it, how much time it will be taking for its manufacture as well as setup time, what kind of jigs and fixtures it will be using it. So details can you can get from your route sheet. Okay. Now the second most important term is your scheduling. Scheduling. Routing is over now. Now it is your scheduling. Scheduling. Schedule means I think you are very much acquainted with the word schedule means time. It deals with your time. That means, in short, I can tell you that scheduling is when and where each operation will be done or performed, which is required for performing for producing the product. That means scheduling it determines it determines it determines by which order will be taken up, which order will be taken up on which machine on which machine in which department in which department at what time And by whom? By which operator? By which operator? Operator. So in which sequence it will be done? So loading and scheduling. Loading means, so this is your scheduling. Loading means which machine you will be using for your using for a manufacture of the parts. So objectives of your loading and scheduling is to have maximum utilization of your resources, and your resources are your men, machine, and materials. So this is your scheduling. Scheduling is and the factors affecting scheduling are. I think you got it. What is scheduling? Scheduling is a time frame by in which machines work will be done, in which departments it will be done, at what time it will be done, and which operator will be doing all these things. So that there is no mismatch, no overlapping. So all the works can be performed simultaneously, proper utilization of men as well as machines. No, we will try to keep scheduling is done in such a way that no machine is kept that means idle. It is the maximum utilization of machines. I think it is 100% utilization is not possible, but we can reduce the idle time of machines. So that's why scheduling is done. Factors affecting factors affecting scheduling are. Number one, your internal factors. Internal factors. Number two, your external factors. Okay. Internal factors means what are the inventory you are having with you, and what is the time you require to manufacture each component. Then after that, what is the time for your assembly time, then final assembly. So all these are comes under your internal factors. Even what are the equipments available for you within the plant itself, so that you can manufacture it. And under external factors means your customers. That means what is the customer demand, what is the quantity that the customer is demanding, what is their delivery date, and as per their delivery date, can you able to manufacture this number of products or not. So all these factors are taken into consideration according to the scheduling is done. So if you cannot able to satisfy it, you have to use additional machines and additional people. You can go for the overtime. More number of employees can be employed. So all the and more materials will be purchased. So accordingly, seeing the customer demand, that means seeing on your external factors, that is the customer demand, quantity, time of delivery. You'll try to frame a work what you need it further. Whether you need extra materials or not, whether you need extra manpower or not, whether you need some machines or not to manufacture the subparts within the plant itself. So this is your scheduling. And usually the again there is a Gantt chart. Scheduling is done by your Gantt charts. What are these Gantt charts? These are these are used for the scheduling. These are the scheduling techniques. Scheduling techniques. Okay, what happens? It is that means it is in the form of a bar chart. Okay, I will show you what how you can draw your Gantt chart. It is a modified bar chart. It's a very important term. It is a modified bar chart in which your horizontal lines, I will show you. Okay, in which horizontal lines or sorry bar horizontal bar chart. It's a bar chart, na? Hmm. Hmm. Horizontal bars are drawn. It is a modified bar chart in which horizontal bars are drawn for each activity, for each activity in proportion to the in proportion in proportion to the time required, okay, for completing it. So actually what happens that for completing it. So if you draw the Gantt chart for any product, it will give you an immediate comparison between what has been planned and how the actually process is being going on. If there is any deviation, accordingly you have to take further steps and you have to improve it. So I will draw one Gantt chart here. So it's a means of just you note down, it's a means of comparison. Means of comparison between between the schedule what you had planned as per your master plan, what between the schedule and that means the actual and the progress of actual work, schedule and actual work. So I'll show you. Suppose there are three sections like section A, section B, and suppose let's say section C. That means a part has to be processed through three sections A, B, and C. Okay, and I'm dividing it week one, week one, week two. Suppose let's say for 4 weeks, week two, week three, and then it is your week four. So how you will know the progress? For planned or scheduled job, you are showing by dotted lines. Okay. And for actual work, actual, suppose let's say I am drawing like a hatch line in this way. So this is a symbol that we are using it for planned dotted lines and for actual this is the way. Suppose section A we had planned that the work has to be completed by week number 2. So planned I am suppose drawing it was a planned one. Section A your work should be completed by week 2. Okay. Okay. And now you have to see whether actually in section 1 your work has been completed or not. Now I am drawing actual work. Okay. Now, in this case, you can see that my planned work as well as the actual work are both are same. So there is no deviation of plan. So this is the Gantt chart I have drawn it. Next, then after completion of the work at section A, it will go to section B for further work. For suppose section B, it was planned from suppose let's say from first to second. Okay, first to second. Then then it will then we will see for section B. Section B, but it has increased. So there is a deviation. It will help. What then you can identify what is the reason behind it, how you can rectify further. So this is your Gantt chart. Then again for C, suppose let's say it was planned up to for week one. After then this is in this case these are my I am giving you one example. Okay, I think now it is clear what is the use of this Gantt chart. You can know how you can compare.
Yes, ma'am.
Okay, so now here comes your problem. Okay, now we have started learning scheduling. It is a time frame. Now machine loading using That is the most important section of this your first module. That is machine loading using Johnson's rule. Using Johnson's rule. Okay. Okay. Now you know that one part has to be processed through many machines. Okay, Johnson has developed one rule so that you can know that the part should be processed through which machine and in which sequence of work should be done. So you know that machine loading, that a word you I have used the term loading. Loading is defined as assignment of work to any machine. Okay, that machine as well as men also. Okay, so that means, so in other words, it can be loading means just, okay. Loading, loading means assignment of work. Okay, assignment of work to a facility. Why I am using the term facility? Facility may be man or machine. Okay, so this is your loading. And Johnson's rule is the most popular method of assigning jobs in a best optimum way. So that job can be that means produced with minimum time and minimum idle time of the machine is there. That means with minimum time you can produce the part and the idle time of machine can be reduced. I have told you that it's not possible that all the machines will be running 24 hours. It may happen that a few machines will be remaining idle. But when the machine is idle, means it's a wastage of our productivity. But Johnson has managed in such a way that we can have the minimum idle time of the machine. I'll show you by means of one example. Let's say this is one job, and but his rule is used for mostly two or three machines. So first I am using it for two machines. So first it is your job. Let's say it's a machine one, then it is your machine two. Machine two. I'm telling you the rule, it's very interesting and very easy to calculate also. Okay, suppose it is a job number one. You know that a part has to be processed through various sequence of operations. So it is a job one or the first sequence of operation. It will be done by machine one first and then machine two first. Then suppose the time taken by machine one is TI1. Okay, and it is taken by machine two is TI2. So similarly for 2, 3 it is T21, 21, T22. Likewise for up to n machines, it will be T, Ni, and this is the T, sorry, it is N1, N1, and this is N2. Okay, the rule, Johnson has ruled that you have to find the minimum time among T1 and your T2. Okay, then if the minimum processing time requires machine 1, place the associated job in the, just listen carefully. It's a rule that if the minimum processing time requires machine 1, place the associated job in the first available position in the sequence. Okay, it's a sequencing means you have to determine the sequence of jobs that has to be done. If the minimum processing time requires machine 2, place the associated job in the last available position in sequence. So I'm giving you one example. I think when I will work it out, Then these are the way. Shall I tell you the rules, or while working out you can understand the rules? I think while working down you can understand the rules. Okay, this is the problem number one.
Yes, ma'am, that will be better, ma'am.
Okay, okay. Problem number one. Okay. So this is your job. Time taken by machines, in hour. Okay. This is your machine one. This is your machine two. Suppose, okay, let's say there are six jobs. One, two, three, four, five, six. Okay. Hmm. Time taken by machine one is your, let's say it is 5, 2, 13, 10, 8, 12. Here it is your 2, 4, 3, 14, 1, 2, 4, 3, 14, 1, sorry, wrong one. It's your 4. Here it is your 4. 4, it should be 3. Let me erase this. It is 3. Here it will be, it will be 14. 14. It is 14. It is 1. And it is 9. It is 11. Okay. So now I'll tell you how to sequence the jobs. You can see that 6 jobs are there processed by 2 machines. So first rule, Johnson says that you have to see in the machine 1 which is the shortest time. Okay, we can see that 2. 2 hours is the shortest time taken by job number 2. Okay. So, okay. Here in machine 1, from machine in machine 1 as well as in machine of 2. Machine 2, which is the shortest time out of all this? I think this 1 is the shortest one, 1 hour. This 2 is the, it's not 2, it's 1. Can anybody see that? This 1 hour is the
Yes,
shortest
madam.
time. Okay. And but this one is at machine number 2. Okay. So at machine number 2. So the as per Johnson's rule, when the shortest time is taken by the machine 2, you will start filling the, and this shortest time 1 is for job number 4. Job number 4. Okay, job number 4. Then you have to start filling that sequence from the right hand side. That means you will write from here. So 4 will be the sequence from the right hand side, because it is this 1 hour is for the machine number 2. Have you followed this thing? I'll repeat
Yes,
again.
madam.
Okay.
Ma'am, can you repeat?
Okay. See, you can see that from all of these timings, this 1 hour is the shortest time among all the timing, and this 1 hour is consumed by machine number 2. When the shortest time, as per Johnson's rule, when the shortest time is consumed by machine number 2, you will start the filling of the job from right hand side. And if when the shortest time is consumed by machine number 1, you will start filling that job, corresponding job number from left hand side. As it is from the machine number 2, we have start filling the sequence of job from right hand side. That is, it is for the job number it is 4, and I am erasing it now. This sequence I am completely cutting it. Okay, I want to cut it. I am cutting it. Just wait, I am cutting it. Now forget this job number 4, I've already allocated. My main aim is I have to schedule the job sequences. So first, so last, that means all the work, lastly, your work will be processed by job number 4. Then after, when one we have excluded, now the second, now the next is out of remaining times of machines 1 and 2. I think this 2 is the shortest one, isn't it? And this 2 hour is consumed by job number, it is consumed by machine number 1, and it corresponds to the job number 2. So, as per Johnson's rule, when the shortest time is consumed by machine number 1, we should start filling the job from the left hand side. So, now we will keep the job number 2 here. Okay, left hand side here. This is okay. Now, again, same rule we will follow. Now, we will cut this one also. Okay. Now, have you followed this thing? Why extreme right and extreme left and extreme right? I have kept the job number 4 and job number 2. These are the job numbers. Right? All of you got it?
Yes, ma'am.
Okay. Next, out of you tell me the which one is the shortest time out of this? I think this is 4. This 4 hour, isn't it? 4 hour is the shortest time. It corresponds to your job number. Tell me the job number.
One.
Job number 1 by machine 2. As it is consumed by machine number 2, we will start filling from the right hand side. Now we will place the job number 1 here. Okay? Is it okay?
Yes, ma'am.
Okay. Now you cut the sequence. Okay. Now after that, which one is the shortest time? It is 13, 14, it is 8, and it is 9. 8, 9, 12, and 11. So this 8 one, I think this is the shortest one, isn't it?
Yes, ma'am.
Yes,
8.
ma'am.
8 corresponds to your machine number 1. So you will start fill, and corresponds to job number 5. And it is by machine number 1. So you will start filling from here. You will consider it will be your job number 5. Okay? And now you cut this one. Now what else are remaining? It is job number 3 and job number 6. And it is so, I think, from all 13, 14, and 12 and 11. This 11 is the shortest time by machine number 2. So it belongs to your job number 6. So you will put job number 6 from right hand side here, because it corresponds to your machine number 2. Now you cut this. Okay. And the remaining one is your third one, third job. It corresponds to your machine. 13 hour is the minimum one. You can just add 3. So this is the sequence of work that you will be doing it. 2, 5, 3, 6, 1, 4. Is it okay?
Yes, ma'am.
Okay, so this is your Johnson rule. In the next class, I'll tell you another example of how to use the Johnson rule when you have 3 machines.